I really wish that I had been on second because I'm not sure how to follow that presentation, which was absolutely tremendous, genuinely. So thanks very much for that, Tim. I'm kind of standing here thinking, what the hell have I been doing with my life? and to make it worse, I actually put some slides together a few weeks ago in quite a rough format on the basis of going to make them all pretty and visual and all that. Yeah, that didn't happen. So there's going to be a lot of text coming up. So don't worry though, the content is like, I don't know, close to average anyway. Anyway, yeah, DataOps. So show of hands, who commonly uses or even has heard of the term DataOps? Because it's London, no one knows what the real numbers are, right? Because half the room's heard of, and you just can't, I can put my hand up. Like. Anyway, yeah, so I guess to kick off and I'm kind of focusing on data science because, you know, that's kind of what I've typically been involved in. I suppose I should tell you who I am. I'm currently the Chief Data Officer for a startup called Future Anthem. I've been working with for a while, which is in the gambling sector. Yeah, so we had all the nice ethical stuff there. Now it's like the big bad devil from the gambling sector. We're actually doing some good ethical stuff as well, but I'll chat to you guys about that later on. But you know, as previously head of data science, I've run a lot of analytics teams, and like the whole concept of data ops to me is like I kind of bore people and rant at people about it a lot because it's so fundamental. So yeah, I guess to kick off, you know, what is data ops and kind of especially for data science, and I very purposely, as we kind of scroll through these here, didn't show a reference architecture, and the reason for that is because, you know, at a high level, all it really is to me is, you know, we want to land data. You know, the first presentation talked eloquently, showed a nice reference architecture. You know, clearly it should all be about ELT these days. In fact, you could almost take away the E because it could be about SLT streaming, but you know, it is so unbelievably cheap to store data that, you know, the old-fashioned concept of why do you want that? Well, tell me the 10 fields you want. It's like we've got SQL boxes and server rooms, and right, it's so cheap. Like Jez could cover our data storage cost and his credit card, right? You know, but it genuinely is. I mean, you look at your cloud bills, and it's like, why do we spend so much? And it's all like computing. Like, how much does that storage cost? It's like, oh yeah, less than like dinner last night. So you know, we just store data, and then the next thing, clearly, we need to kind of like organize data, right? And you know, we don't have to put it in any big old-fashioned, you know, data warehouse structures yet. We just need to organize it, put it in some folder structures, understand what data arrived on, and you know what time it arrived on, etc. And then we want to do some stuff with it, and that stuff could be a whole range, right? And the fundamental is lots of different people in the organization need data. And to me, the whole concept of data ops is, regardless of what your data needs are, from, you know, one person in the corner doing one thing to a vast conglomerate doing a million things, it needs to be kind of one pipe running through the organization, because then you just pitch everything else that you need to do. So it's not about what does a data scientist need, what does a data analyst need, what does that person over there that likes poking buttons and dashboards need. It's like, actually, it's just a single pipe, and then you deliver each kind of individual and team's needs from the same place. So, you know, it's a pipe run through a business. It should be automated, you know, so clearly we shouldn't be trying to organize data on a routine basis, right? What's the source of the data? What does it look like? What do people need to do with it? Do a single job to, you know, create a set of processes around it, and theoretically that's done until the next thing. It should be decoupled, right? So, you know, technology is great these days, but there's new tools on the market every day of the week. So the last thing we want to do is, you know, buy in a big funky new tool, and it's actually great for 3 months, and then, so, you know, microservices and decoupling architectures, I think, are just, it's actually, I think, impossible to have a proper data ops concept, given that we need to run across multiple teams without having kind of microservices concept at least, and decoupling is just like the most important thing. And again, it's pretty straightforward. Right? What do you actually want to do in life? Or for a data organization, I want to bring data in, I want to process it, organize it, do some level of curation. And curation could be, you know, really advanced feature engineering for a data science team. It could be some pretty straightforward KPI metrics for a dashboard, but ultimately it's just creating data. We can do all the kind of like fancy data science stuff, you know, do through a life cycle. We want to prototype models, train models, evaluate models, we need to deploy models, we need to send out a whole load of scores. Again, in a more kind of like structured world, we want to again, the same pipe to then push data into a more structured database, if that's what we need to do. Presentation layers, maybe put in some cubes, whatever we need to do. Push it out to a visualization tool, Tableau, Power BI, Looker, etc. You get where I'm going here. It's a single pipe that we deliver all our processes from. So, pretty easy, right? So I've been involved in 2 kind of implementations of like DataOps over the years. The first one we didn't call it DataOps, I didn't know it was called that. That was a term that somebody came up with, and I thought, that's kind of like what we do. And then the second time we thought we were a bit cooler, so we did. But yeah, first time we did this, recruited a data science team. Had a whole load of blockers, brought in a data science team into an organization that was used to dealing with analytics, and I don't know why we made everybody really angry. Brought in some data science. They were nice people. Some guys, some girls. I mean, they were genuinely nice people. They were smart. But yeah, we really made people angry. Like, we get access to some data so that we can build some models and predict things about the business and make some more money. Apparently, I was in some pretty bad meetings. Like, people banged tables. And so that took a while. And then we kind of managed to get some data in a different way. And we got to this thing that we called manual production, right? Which was, we didn't have any proper pipelines at all. There's some smart data scientists who built some models. And we just wrote a whole load of scripts, and we somehow managed to get them interfaced into a CRM system and to do a few things on our website. So it was fine. The scripts used to fail every kind of 3 days. But we had that, so it was kind of manual production. And then we kind of said, well, we've kind of proved some value here, and we've made some money for the company, and we've kind of shown you that this stuff kind of works. So we should probably just have a proper infrastructure. And and we had a good understanding of what that needed to look like, and we kind of started scoping it out, and we got in some external people. And the whole load, then were people even angrier, because then it was like you're telling them, that they weren't doing their jobs properly, and they banged tables harder. People swore at me quite a lot. So yeah, with the whole of the blockers, with the kind of lack of data access, massive politics, and then there was a whole investment case thing. I spent more time in the finance director's office than I would care to imagine. And then we did a little partner selection, and then we actually started developing this thing, which was like an end-to-end production infrastructure, which, believe it or not, after all that other stuff, was quite the easy bit. And then we eventually kind of completed it, and we kind of had a whole a brand new infrastructure, and we kind of went end-to-end, and we kind of raw data coming in, and a load of different things happening, and models in production. It took about 3 years, and I would say the actual development time on that was about, 3 months. And most of the rest of it was, people banging tables. And then did it another time, kind of recruited a data science team and agreed some business objectives, did some partner selection, requirements and architectures and stuff, and kind of started the development, and got to, okay, it's not all singing, all dancing, but got to a kind of a completed development and pretty much the kind of DataOps structure. It took about 6 weeks. One of them was in a PLC, and one was in a startup. Can anybody guess which was which? So yeah, so that was the reality. So why did that first example, which was clearly the PLC, take 3 years and clearly most of my hair. So when it first started off, right, the view was that we were a front-end data function. That was it. We were, because what we used to deal with was analytics. Analytics was, here's a team of data analysts, maths degrees, physics degrees, engineering degrees, but they're data analysts. They code in SQL, so that's fine. We didn't really see what was happening. Data going into the organization, data moving through the organization, didn't see any of it. We had a nice SQL database, and the analysts queried the database and visualized some stuff probably in those days in Excel, maybe a bit of Tableau, and everybody was dead happy. So getting access to that data was a massive challenge, because people were like, there's a wall here, there's your SQL database there, and everything before here, you don't concern yourself with that. But clearly we did, right? So next thing, organization didn't have any concept of a single pipe, right? At the opposite, there was just data everywhere. There was data in people's laptops. There was Excel workbooks that had become databases. And when you told somebody like, what's that 80 meg file on the shared drive in Excel? It's nothing. What are you doing with it? It's like they've built their own, they're not a database developer, but they built a database in Excel, and they're like, well, we need to not do that anymore. Like, half the finance department runs off that. It's kind of like, so, that's kind of like, what I do want to see. Everything was in SQL, and like, as was mentioned earlier on, SQL's a brilliant tool. It's a great programming language. We still use it every day in a Spark environment. But what we had was a single box, and as soon as we said we need to do things that are a bit different from that box, banging tables again. But as I said, we got models down in production manually. It took a long time, and ultimately people kind of eventually believed that we probably needed some better tools. So what's the main takeout, right? Fundamentally, and I've got a lot of blame here as well. It wasn't just all those other people, as much as I'm the hero in this story. But no, we instituted the team without properly thinking about what support network was required, right? So when I think back to it, it's like, well, how could I possibly have expected that I was going to succeed? Of course it was going to fail, Like, so I made the mistake that everybody made, and it was 2015. I'll take some defense there, but 2015, what you do? Go out and hire some data scientists and think about everyone else later on. So we basically tried to implement data science into a BI world, and of course it wasn't going to work because you can't just do that. I mean, what we're really trying to do is a kind of culture change without telling anybody. So yeah, I guess, and just to move on though, because people that do talks a lot will know that in every talk that you do, you have to have something that's a bit controversial, right? It's just like, it's one of the rules. So, if you think about it, like, this has all been solved. Like, I'm not talking about anything here that isn't off the shelf within, your standard cloud vendor, for example. So it has been solved already. I kind of believe that cloud has now made this available to every business, right? I'm working in a startup with like 6 people, and we're using, best in breed technology, right? So, that wasn't possible 7 or 8 years ago, or 10 years ago, certainly. It wasn't possible, right? So that's kind of taken away those barriers. So, I kind of posit that it's difficult for people, or it's difficult to think that this can be true, but I genuinely believe that the only true blocker to having kind of like a really advanced organization, a really advanced DataOps type structure is purely company culture and politics, and the desire of people to actually do it. But unfortunately, I speak to, I've run a few different data science teams. I'm still in contact with all of those poor people that I brought into that organization, and people shouted at them. But it feels like it's still the absolute biggest blocker to data science, just that politics and culture, which is a pretty sad place to be in 2019, because I was standing up chatting about this kind of stuff in like 2016, and it's kind of weird that as technology moves on, that kind of culture and politics, but doesn't really seem to be as much. The last talk there, sorry, I can't remember her name, but mentioned the fact that we're still in that place of everyone talking about AI. And only a few people, and I'm not including myself, including these guys who spoke before, actually doing it. And I actually love the fact as well that in that previous talk, because I go to a lot of the startup events these days, and like everybody's got a mission, like everyone's got a mission. And then I was like sitting halfway through that talk, oh, these guys actually do have a mission. Oh, wow, actually, that doesn't happen that often. So yeah, and then, look, none of this stuff's going to be groundbreaking, right? It's all really simple, but like recommendations on it, I think the last time I did this deck is like, you just do the same deck all the time with these talks and then refresh it once every few months. But I think someone asked me for some recommendations. So, if you try to do this for the first time, right, like it's pretty straightforward. Just do a proof of concept. Don't hire anybody, right? Get a contractor in that knows what they're doing. Ideally, if you can only afford one person, get someone who's basically a data engineer that knows data science as well, because they can kind of do the pipeline, and you don't really need complex models. It was the first time you've ever done it. So, if you just want one person, just get someone. Don't just go and get a data scientist who's never heard of engineering, because like, everybody will get angry at you. The data scientist will get angry for hiring them. Finance guy will get angry because you're not producing any value. Everyone will be angry. Like, honestly, it makes people really angry. So yeah, find a bit of value. Like, again, pretty straightforward stuff, but like just work out a proper stream. Implementing data science without saying what's going to change. Try to talk about implementing AI, about saying, where does my data come from? How do we process data? What's the business usage? But and a lot of people do that whole strategy bit of, this is all my business use cases. Here's how we're going to build this, without saying, how does this go from end to end? Is a fundamental for me. and the last one wasn't that good, so we'll just leave that. If you try to do it for the first time, if you're in a situation, which I think a lot of people are, where you're in a data science team, everybody hates you, or maybe they think you're okay, but your models aren't in production, you're getting a bit frustrated, know all the value you can produce, but you don't have these kind of processes. You need to identify your decision makers, and that's probably fundamental. You probably already know. If you don't, you need to work out the infrastructure and support that you require. And look, this happens all the time. It genuinely is unacceptable to bring in a data scientist, give them a laptop, a login to a SQL database, and say, go make me money. But it happens like every day of the week in London. The analogy I always use is like nobody would hire a marketing, like a CRM person, and say, "Here's an Outlook account, go make me some money," right? They would bring in a CRM person and say, we've got Adobe Campaign, and we've got a whole team of people that can query databases for you, and we've got an illustrator who can like build out the visuals, right? But people just bring in data science, say there's a laptop. So, I don't think it's acceptable, but you do have to identify, it's that simple stuff again, but who's got a budget? There's a lot of people, and I've done it myself, you spend too much time trying to convince the wrong people. If they don't have the budget, it's just a kind of fun conversation in the pub. And unfortunately, and I don't like having to do this, but you do have to speak their language, right? You need to talk to them, you need this infrastructure, we're going to deliver your results in a safe and robust way. These results, what do they do for you? They drive on-site recommendations, it's your marketing spend optimization, your early life cycle CRM campaigns. We drove X amount of incremental revenue last month. And tell them you're making the money, and then say, and it's all just about to break. Current processes we've used, right, they're held together with string. They're not going to get is there, we need something that's robust. So that's all kind of like great and easy. However, I can actually think, and I spent a lot of time getting to that stage, but I kind of think like to really talk about data ops, because all that really talks about is the pipe that goes end to end from data coming in to like models in production, so models are in production, great. We're scoring models every day. We're scoring models every minute, but need to go a bit further because it's kind of irrelevant until it has some sort of impact on customers or your business processes, right? Next big problem for data science, you're not going to own your delivery channels, right? You're not going to own CRM, you're not going to own your website. So theoretically, even though your model's in production, there's still a gap. And then you get into the kind of like, I guess, we kind of need to extend that whole data ops thing to the overall company culture. So it's like a further step than probably we had before, because no point in developing like a killer recommendation engine, API interface is gone, pushing up to your CMS, I'm going to make loads of money, but the marketing team kind of want to just like look at a dashboard and then make a campaign based on that, and that's happening in the real world, right? I know data scientists built a recommendation engine and this happened, and it's still not live. He's actually given them the API, and it's like, well, that's not really how we do things, because I've got this like KPI dashboard, and so and I'm kind of, I was going to apologise and rude to marketing people. If there's any of them, I do apologise. It's not nice, but yeah, I'm exaggerating to make the point. And yeah, I guess the question to finish, right, and this is genuinely, this isn't like I'll just say a question because it's a standard way to finish. Genuinely interested in this is that, so, as I said, I purposely didn't put up a reference architecture earlier because, to me, data ops is more like a concept than I do it like this. There's a concept that you need to, abstract everything away, that you need to decouple everything, but, you can do it in Azure, you can do it in AWS, you can use S3 or Azure Data Lake or Databricks or Delta Lake or, name 100 more things. So it's not about what tools you use, it's more of a concept. So it can be, implemented a number of different ways. For me, like this key element is this kind of like route to deployment, and it's something that I've honestly wrestled with in terms of data science teams over the years, which is, so I guess to kind of like call it a traditional model. Data scientists will build a model in like Python or R using libraries like pandas, and then it's kind of like thrown over a fence to an engineer, and they're then responsible for deployment. And that kind of means that they need to rewrite the model into something like Scala or like PySpark in the recent years. So there's going to run in something like Spark. Again, I'm assuming data's at a certain volume, you need like a Spark type infrastructure, which is typically the ones I've dealt with. Or they're going to have to containerize the model. But essentially what you've done is you've you've basically created like two separate jobs, right? You've got a data scientist job doing all this stuff. And then I guess we then kind of moved into a different place, like, well, doesn't really make sense for a data engineer to have to rewrite a model that a data scientist has built, because you question why the data scientist is, what are they bringing if the engineer's rewriting it and not efficient? So then you get to the stage, well, actually, you could just get data scientists to deploy a model. That means that at some stage in the process, they're going to have to write in something like Scala or Spark, or not writing Spark, but writing Scala, writing PySpark. And I guess the question is, like, both are valid, right? My kind of preference is becoming number two. I'm kind of getting to a place where I don't really see why we should have a data scientist like using things like pandas that aren't ever going to get into production, that have to be in some way altered before they get to production. What we've done recently are data scientists all writing PySpark, which means that every single prototype that they create is already theoretically ready to push to production, once it goes through the process. And again, I'm not saying that I don't think there's a right or a wrong, but yeah, I'm kind of interested in, and I guess even a bigger question, we had a few data scientists coming over this summer. They were actually in from the master's program from Eden Smith on Nurture. So it's like the Nurture program. They're doing a master's in data science. Their 3-month internship was their kind of final like project, and then they were available for kind of hire. So they were really good, like really smart, brought some great value over the summer. One of them stayed with us actually, which is outstanding, and so all great. But when they first came, so bear in mind doing a master's in data science, so they spent a year, and kind of they're like, okay, done the interview and everything, and they hadn't really heard about things like Spark. They didn't really know what a big data infrastructure is. And it's no disrespect to them, right? Because they're only learning what they're taught at the course. But it kind of surprised me. So how can you go through a full year without really getting told about the infrastructure and deployment and production? So yeah, I guess it's a question if, I don't know if we get time or not, but should we have data scientists coding in more big data languages, or should it be that more traditional paradigm, I guess is my question. Or I can take your questions. I mean, I'm kind of open either way. Stunned silence.